The navigation system on board a modern commercial airliner is a complex yet fascinating subject. Over the years, GPS has become a crucial component of these systems, enabling highly accurate navigation. However, GPS is not without its limitations, being susceptible to issues such as interference and jamming. If you're curious about the significance of GPS in aircraft navigation, you're in the right place. In this video, we'll explore this topic in some detail. Welcome back. My name is Deepak and I'm a captain and instructor on the Airbus A320 family. Modern airplanes incorporate various systems to aid navigation. As technology has advanced, these systems have evolved significantly, becoming highly sophisticated and reliable. In this video, we'll focus specifically on GPS, examining its role within an aircraft's navigation system, along with its limitations and challenges. As always, every effort will be made to keep the content light and easy to follow. The Global Positioning System, in other words GPS, the project was initiated by the United States Department of Defense in the 1970s and is now a primary navigation source on modern planes. Aircraft continuously monitor their GPS position, which is often the most accurate navigation system available, allowing maneuvers with an accuracy of up to 0.1 nautical miles in certain circumstances. To provide further context, the GPS system encompasses a constellation of 24 operational satellites that transmit radio signals to users, which also include aircraft. There are 31 satellites, but there would be at least 24 satellites that are operational for at least 95% of the time. Modern aircraft are equipped with GPS receivers that capture signals from these satellites. This information is then used by the onboard navigation system, often in conjunction with other systems, to establish the aircraft's position. When it comes to position computation on a modern plane, this would commonly employ a mix of GPS and IRS position to compute something called a GPIRS position. Now, in case you're wondering what the IRS is, the IRS stands for Inertial Reference System. It is a self-contained onboard navigation system that can track the aircraft position without any external references. In other words, it is not dependent on any external aids when it comes to determining an aircraft's position. For GPS to be usable for an aircraft's navigation system, there is a need for an aircraft to detect at least 4 satellites that make it possible for the system to determine the aircraft's precise geographical position. Although GPS plays a central role in a modern plane's navigation system, it is susceptible to several limitations. First of all, there are GPS black spots, where there may be not enough satellites in range to obtain a position. Clearly, this is not acceptable if the aircraft was operating with sole reference to GPS when close to the ground. GPS is also susceptible to jamming and interruption for various reasons, a concern that has grown increasingly significant in recent years. Let's explore the issues of GPS interference and jamming in more detail, along with something called GPS spoofing. Aviation operations increasingly rely on GPS, or the broader Global Navigation Satellite System, or GNSS, to enhance navigation performance and support air traffic control surveillance. However, the full benefits of GNSS can only be realized if its signals are protected from EMI, or electromagnetic interference, which can degrade or disrupt GNSS services. Such interference prevents onboard receivers from locking onto satellite signals, effectively rendering the GNSS system ineffective or degraded for users in the affected area. Interference with GNSS can be intentional, in other words, jamming, or it can be unintentional, and it can come from systems operating within the same frequency bands as GNSS or from outside those bands. Spoofing is a little bit more insidious, involving the broadcasting of counterfeit satellite signals to deceive GNSS receivers, causing them to compute incorrect data. In simple terms, jamming blocks the signal while spoofing sends false information to the receiver, corrupting its position. So how do pilots know if they've been affected by jamming? Well, indications of possible GNSS interference include onboard system indications such as degradation in the aircraft's navigation accuracy and spurious time indications. GNSS interference can also impact the functionality of other aircraft systems. Just by way of an example, it could interfere with the normal functioning of the GPWS or the ground proximity warning system, potentially issuing false warnings and so on. The navigation systems could be affected, which can lead to route deviations or uncommanded turns. Now, this can potentially result in airspace infringement or loss of separation with other aircraft, which can be serious. To counteract GNSS interference and spoofing, several defenses are in place. Pilots can rely on conventional radio navigation aids like VORs and DMEs, which are unaffected by GNSS interference. If navigation accuracy is in doubt, pilots can request for radar vectors, in other words, headings, from air traffic control. Airlines also implement measures to mitigate GNSS interference risks, including analyzing in-flight event reports, informing crews about affected areas, introducing procedures for specific actions in affected areas, such as disabling GNSS position updates and using alternative navigation aids, also providing training for flight crews, and so on. Alright, so there we have it, a high-level overview of the significance of GPS in an aircraft's navigation system and the sort of challenges that go with it. A modern commercial airliner's navigation system is highly complex and sophisticated, with GPS playing a key role in its accuracy and reliability. However, the increasing incidence of GNSS interference and spoofing poses significant challenges. Airlines, civil aviation authorities, aircraft manufacturers, and other industry stakeholders are collaborating to mitigate these risks and ensure safe and reliable navigation. Well, I hope that made some sense and it wasn't too difficult to follow. As always, if you have any questions or comments, or you would like a certain topic related to aviation offline covered, please put that in the comments below and I shall do my best to cover it in a future video. If you liked the video, please give it a thumbs up and share it along. Thanks ever so much for your time and support, and I look forward to seeing you in the next one again soon. Thanks very much again, and I wish you a great day.